Okay, let's go over making a best fit line or least squares regression line or model for linear, exponential, polynomial, logarithmic. There's a couple choices we have. So first you want to type in your data. And this data is all from um, page 498 example data they give us. So the first thing we want to do is figure out what model fits it best. And to do that, we're going to go up here to Insert and Chart. Keep in mind that you want to click over here so that Google Sheets doesn't try to help you. So if it comes up as no data, then you're good. You're going to want to double click that, come down here to X-axis, and you want to add your data for the X-axis. Now you're given the age and passing yards, and this is going to be identifying the connection between how old someone is and their passing yards. So in this case, it makes more sense to say the person's age is will determine their passing yards. So we will select that as our X data. And then we want to add our Y data. So click down here and add a series. Select our Y data. Making sure we don't accidentally include that part. Click OK. And we don't want a column chart, we want a scatter plot. Okay, so now we have our data here. So now that we have our dot plot fixed, and if you click off, that part goes away. If you double click, brings us up. So now that we have our dot plot, we want to put our equation on it, our best line, and go down here to Series, and scroll down and we want to add a trend line. Now when we add a trend line, it's going to give us this line right here. However, just seeing that line isn't very useful to us. We want to label it with our equation. And now we have our equation for it. And if you double click this part is extra. You can increase the font size to something a little easier to read. So we have our equation, we have our line. We want to analyze it to try to find the best fit for it. So a line, it looks like it's decent-ish. I mean, this one's a kind of a sucky correlation to begin with. But we can get a gauge for how good the correlation is with this R squared. Remember, that's a measurement of how much error there is. Now this one gives us an R squared of 0.001. If you recall back, R squared, that is saying anything from 0 to +1, where 0 is no correlation, and 1 being that it has perfect correlation. So this one's basically 0, so this has a really sucky correlation if we go with a linear model. So if we click on, oops, go back here to series, trend line, right here. So type a trend line. If we click on that, we have some options. Exponential, polynomial, all these other ones. So let's try exponential. That gives a 0.019, so a little better, but still not fantastic. So we'll try polynomial, 0.176. That's quite a bit better than the other two, even though it still sucks. We can try logarithmic, which is horrendous. It actually is a 0. Power series, also a 0. And moving average, I'm not even going to worry about that one. Basically, these first 4. Don't worry about either of those. So out of all these, the polynomial was the best fit, even though, like I said, kind of sucks. But we're going to roll with it, because the book wanted us to use this one for some random reason, even though it sucks. So our goal is to make the residual dot plot. In order to get the residuals, though, we first have to get the predictions. Predictions, and this is with a polynomial. To get the predictions, we're going to base it off of this equation here. And we're going to type an equal sign. That's telling Excel that you're typing an equation in here. Minus 2958 plus 536. And to get the x, remember x is the player's age. So we're going to multiply by the player's age. And to do that, we want to click on their age. If you just type in 29, it's going to be a headache because you're going to be typing that for every single one of them. If you reference it like this, when you copy it down, it's going to make your life so much easier. So plus, do the same thing for this one. Well, that's negative, so let's do minus x squared. So 13.7 times x squared times age. Click that. And we want to do shift 6. That's called a caret symbol. That thing right there. And that's saying exponent of 2. And when we hit enter, it now calculates the prediction for someone who is 29 years old. Meaning 29 would be about here. So it's saying if you're 29, this value right here is what it's predicted to be. So the whole reason why we type the equation like this is so that we can copy it. Click and copy, or you can use Control-C. And you can highlight all of that and paste it, or Control-V. Now notice how each of these is referencing the age to the left. If we had just typed 29 up here, it wouldn't have referenced it correctly. So we have our predictions, we have our passing yards. Now we can get the residuals. Residuals, if I can spell that right. If I spelled it wrong and you tell me, then good for you. I ain't gonna fix it. So our residuals for the polynomial. Residuals are the actual, so the passing yards, minus our predictions. So for this first one, our residual was 1,245. We can then copy that and paste it. And if you're curious, the shortcut I was using to highlight everything is I click on one cell, and then I come down to another, I hold shift, and then I click, and it highlights everything in between. That's just extra. Okay, now we have our residuals, we have our age, so now we can create our residual plot, or our residual scatter plot. So same way that we made this one, click Insert, Chart, add the X, okay, add the Y, which is now our residuals, okay, and we do not want a column, we want a scatter plot. Okay, now, this one, if it was a better fit, meaning if this was, let's say, like 0.5 or 0.6, this would look really random. It's kind of hard to judge if it's truly random because it's such a sucky correlation, but this one does look like it's randomly scattered. And one way that you can identify that is about half the dots are above, about half the dots are below, and there's not any pattern. So let's say if there was like a pattern you could see going like that. It's like if none of those existed, you could maybe see a little pattern, but this one is good. What that is telling us is that a polynomial is a good representation for this data, even though it technically sucks. Anyways, this is the best version for this sucky data, is basically what I'm getting at. Jumping to page 505. Now we have this data. And this is saying that given a certain year, and it references these years based on, I think this is like 1991 or something like that. And it's just adding 1. But anyways, this is the minimum salary of a, I believe it was a football or baseball player, something like that. But anyways, we are going to go through the same process. First, we are going to first we are going to insert a chart. Put our X data. Put the Y data. Do that. And we want to make it a scatter plot. add the trend line, show R squared to give us an idea of how accurate our trend line is. And now we play with the type of representation we want. So right now it's linear, and it's giving us a 0.867. Let's try exponential. That's pretty good, 0.972. Polynomial, 0.984, so that's even better. And logarithmic, and that's clearly terrible. And we're not going to worry about power series or moving average. So let's go with polynomial. That gave us the what looks like the best fit, especially with this r squared being so close to 1. And let's label the equation, how we can actually have it. If you double click this heading, it'll bring you right to the spot where you can increase the font. And I'm also going to turn off that r squared because that is bugging me. Right there. That's just the equation here. So prediction, and this is with a polynomial. We are going to do equals 30841 plus, or minus rather, 4678 times x, which is the year, so left click that, plus 363 times the year, left click that, do the caret or shift 6, and square it. So that's what that is. Hit enter. Now this is our prediction. We can copy that and put it all the way down here. Okay, so we've got our predictions. Now we want our residuals. Residuals, polynomial. And that is from doing the actual minus the prediction. Copy that, take it down here and paste it. And now we want to make a chart for the residuals. So insert chart. X is the year. Y is the residuals. And we get that, and we want it as a scatter plot. Okay, so over here, it's looking pretty random, but right here, we definitely have a pattern, and we do not want a pattern. So let's see if we can kind of identify why. Looking over here, it looks like it's pretty good for here, but when we get to here, notice how there's all these that are right above it, and especially right here, it's doing something weird. It's saying that it's starting the curve back up, which is not exactly what this is doing. Because obviously it's starting down here and it's always increasing. So let's go back to the drawing board. Let's try a different series. Or different trend line. Let's go to exponential, because that one was the next closest. So we can move that down here. So if we go to exponential now we have this equation here. So prediction exponential. So equals 13297 times E. Now E, I'm going to do a little hack right there. Don't worry about what I just did. What E is that is 2.71 something 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 something. The way that you put that into Google Sheets is you type E XP, and that's going to give you this exponential function here. Or if you just wanted the number, you would do E, and oh, that's not with Sheets. Anyways, it'll be EXP, and then whatever you type in here is going to be the exponent of this E number. So what that means here is we type in this, multiply it by E, so EXP, short for exponent, of 0.0898 times X, which is the player's age. So click the player's age, and we will close the parenthesis there and enter. Take this, copy it down, and we get all that. Now, something just a little extra with Google Sheets is we have a bunch of decimals there. Let's just get rid of those to make a little more sense in our life. Okay, so we have our actual, we have our predictions, so now we can get our residuals for exponential. So equals actual minus prediction. We got that, copy it, bring it down. Now we want to create the residual plot for our exponent. So insert chart. X is still going to be the year. Y is now going to be the residuals for exponential trend line. And we want it to be a scatter plot. That's here. There we go. Okay, so you look at this and you're like, oh, there's a pattern here. It's going straight. That is actually good. This is the only good type of pattern. The only good type of pattern is if it is exactly on this line. Remember, the residuals is how far away it is from our prediction. So these dots that are super, super close to the line, those are saying that they are very, very accurate, which you can see here. All of these points here are very close to the line. So right about here at 14 is where it starts getting a little further. At 14, I think that's this one, starts getting a little further. So this pattern is good that it's close to it, and then when we start getting out here, it starts going crazy. So over here, it is random, because about half are above, half are below, and you can see that over here as well, that it gets a little more error as you go along. Okay, so that is how you analyze if you have a good function or not. Now at this point, you are good to finish the video, but just for giggles, I want to see what would happen if we use a linear trend line. Curious what type of residual plot that would give us. So prediction linear equals 10193 times a year minus 73255. Wow. So already really bad. It's saying that the first 7 years there was a negative salary. So that's silly. Anyways, so we got our prediction. Let's get our residuals for the linear. Minimum minus prediction gives us that. Now, little trick. If this little box right here, if you double click that, it automatically fills it down for you. Now let's do another. And we're actually going to use the shortcut. The only way that you can get Google to actually help you is if you click and drag for your X values first and hit Control. I messed that up. So select all of that, hold Control, and select all of that, and then insert chart. It's going to give you this. Just turn it into a scatter plot, and there you go. Ooh, so we have a strong pattern here. So that's what happens when you use a linear model for it. You get a strong pattern saying this is a very, very bad representation of it. So there you go. That was just for my curiosity. That is it.